Is there an alien civilization next door? It's possible-ish. We discovered a signal from the direction of Proxima Centauri, our nearest neighbour star, around late 2020. Named BLC-1 by Project Breakthrough Listen, the signal is still being investigated to assure it isn't just an echo of our own civilization, which is usually what they are. But why not just directly look at planets in Proxima Centauri and see if a civilization is there? Enter the James Webb Space Telescope. One of the aims of the James Webb Space Telescope is a profound one: to search for habitable exoplanets where one day we could look for evidence of life beyond our own planet. Scientists using the new and powerful JWST are looking for lights that could be the final definitive evidence that an exoplanet known as Proxima b is inhabited by aliens. But habitability is no simple matter, and finding another Earth-like planet might be more complicated than you imagine. Keep an eye on the video because things are about to get serious. If you've ever questioned why humans exist just on Earth, you're not alone. We've been looking for an answer for millennia. Another perplexing question is whether we are alone in the universe. Are there aliens out there wondering if they are alone in the universe as well? Are they attempting to contact us? Are they even watching us? These are questions on which we have spent billions of dollars, but we have yet to find conclusive answers. Mars is being considered as the next probable planet to host humanity, with Elon Musk's SpaceX leading the charge to make it a permanent human colony. Microbial life may exist on Mars now, maybe under the planet's ice caps or in underground lakes identified by satellites such as the European Space Agency's Mars Express. These kinds of locations could shield life from the severe circumstances on the planet's surface. Because the type of life we believe could exist on Mars now is microbial, it would not be detected by an orbiting spacecraft's cameras. Instead, we could identify it indirectly by chemical fingerprints connected to life, known as biosignatures. Mars is quite close to the Earth, making it possible to send humans there, though such a voyage would be difficult. However, much further out in space is a class of planets known as exoplanets, which will be the focus of our video today, alongside JWST. What is an exoplanet? Our solar system's planets all revolve around the Sun. Exoplanets are planets that orbit around other stars. Exoplanets are extremely difficult to observe directly using telescopes. The dazzling glare of the stars they orbit hides them. As a result, astronomers employ alternative methods to detect and study these faraway planets. They look for exoplanets by observing the effects these planets have on the stars around which they orbit. The International Astronomical Union adopted the infamous new definition of planet in 2006, which excluded Pluto, now classified as a dwarf planet. Planets must revolve around our Sun. Planets must be massive enough that their gravity forces them to have a spherical shape. Planets must clear their orbits of other bodies. Therefore, they are the largest body close to their orbit. Exoplanets are simply planets that orbit stars other than our Sun, as the prefix exo stands for extrasolar, which means beyond the Sun. We had detected 4,354 exoplanets in 3,218 planetary systems as of October 1st, 2020. Around 22% of such systems have several planets. So far, we've discovered the following categories of exoplanets. Gas giants, they are massive planets having dense gas atmospheres such as Saturn and Jupiter. Ice giants, with frigid gas atmospheres that are similar in size to Uranus and Neptune. Super-Earths are a mix of rocky and gas-enveloped exoplanets that are larger than Earth but smaller than Neptune. Terrestrial, rocky about the size of our planet. You've probably heard of hot Jupiters, which are a common type of exoplanet. They have the characteristics of gas giants, but since they orbit so near to their stars, they have extremely hot surfaces and atmospheres. They also orbit their star very swiftly, sometimes in less than a day. Lava worlds, Earth-sized exoplanets with extraordinarily high temperatures, are another fascinating type of exoplanet. One such example is Kepler-78b, which orbits its star at only 1% of the distance between Earth and the Sun. The surface temperature of Kepler-78b is most certainly greater than 2,000 degrees Celsius. Do habitable exoplanets exist? We don't know for sure, but there's a long list of potential candidates. The nearest identified exoplanet that could support life is only 4.2 light-years away. This super-Earth, known as Proxima Centauri b, is somewhat larger than Earth and lives in the nearest planetary system to us. It revolves around Proxima Centauri, a red dwarf star in the Alpha Centauri triple star system. The minimum possible mass for Proxima b is just 17% more massive than our planet. This latest finding suggests that Proxima b may be even more similar to Earth, at least in size, than previous observations suggested. So what's the deal with this Earth-sized planet? This fascinating alien world orbits Proxima Centauri, our Sun's nearest neighbour. Because the planet orbits in the middle of its star's habitable zone, liquid water and possibly life could exist there. Because of its Earth-like mass, scientists believe Proxima b could not only have liquid water, but also be a rocky terrestrial planet like Earth. However, Proxima b orbits a star that, while close to our solar system, is far dimmer and less massive than our own Sun. Researchers believe the exoplanet is tidally locked and rotating in sync with its star, which means that one side is always facing the star and the other is always facing away. A light side and a dark side. How will JWST prove the existence of life? It is unknown whether Proxima b has an atmosphere. The planet revolves around its star every 11 Earth days, completing one orbit. As a result, some experts believe that radiation from Proxima Centauri may have stripped away Proxima b's air, rendering the alien planet's surface incapable of retaining liquid water. But now that we have JWST, scientists will be able to better comprehend what it's like on Proxima b and unearth its secrets. However, if Proxima b does have an atmosphere, the essential components required for the formation of the biochemical cycles that comprise life, like as water, carbon dioxide and rock, might all be present and interacting on the planet's surface. Radio signals have been detected in the vicinity of Proxima b. But radio astronomers believe that while radio signals have been detected in the vicinity of Proxima b, they were most likely noise from other sources. As a result, any civilization that inhabits the exoplanet may need to deploy strong mirrors or use extremely bright LED-style lights to illuminate their cities because the side of the exoplanet that is free from radiation is constantly dark. From space, the brightness from our planet's night side is the clearest indicator that someone lives on Earth. Our cities emit light, which is reflected in the cosmos. The issue is that our current generation of telescopes are insufficiently powerful to detect lights on faraway worlds. But several researchers have already tested capabilities of the next generation James Webb Space Telescope on the drawing board. The finding? Yes. If advanced enough or bright enough, we will be able to see if another civilization has the lights on at Proxima Centauri. There are various ways to detect the presence of alien technology on another planet. For example, the transit of a vast constellation of satellites in the direction we're heading may allow us to see the light of a faraway world waver. Atmospheric pollution may be detectable from nuclear conflict. Ouch! While these technological signs could be created by natural phenomena like as orbital debris or a comet impact, artificial illumination is distinct from natural starlight. Elisa Tabor of Stanford University and Abraham Loeb of Harvard University put the JWST through its paces. Tabor and Loeb calculated artificial illumination as a proportion of solar illumination reflected from the planet's day side. On this scale, 0% implies that the planet's night side is completely dark with no artificial illumination. 100% means that the planet's night side is as brilliant as its day side. The sort of light utilised by the potential civilization on Proxima b is thought to be similar to LEDs on Earth, which have a distinct artificial spectrum. What were the outcomes? JWST might detect artificial light with 85% accuracy if the artificial night side illumination of Proxima b approaches 5% of the natural day side illumination. JWST's detection confidence increases to 95% if artificial illumination reaches 9%. 5% illumination doesn't seem like much, does it? We're talking about light from a star after all. Even though Proxima Centauri is 20,000 times fainter than our Sun, that's still a lot of light. In comparison, the artificial illumination on Earth accounts for only 0.001% of the reflected stellar illumination. In other words, if Proxima b is home to a civilization as bright as ours, JWST would miss it. Those lights must be 500 times brighter. That's a plausible scenario. Proxima b orbits its host star so closely that it may be tidally locked, with one side of the planet always facing the star and the other in permanent darkness. A civilization on a tidally locked planet may need to focus on illumination infrastructure and, as Tabor and Loeb propose, may utilize very powerful orbiting mirrors to reflect sunlight onto the planet's night side, which our telescopes can see. According to Tabor and Loeb, future telescopes such as LUVOIR, Large UV Optical Infrared Surveyor, may be even better than JWST at detecting the glow of a distant civilization. Both LUVOIR and HabX are expected to launch in 2035, with missions to catalogue and directly image exoplanets. If an alien civilization exists, it is possible that it has already attained this level of urbanization, assuming that technological civilizations live a long time. And here's the thing, we don't know how long technology civilizations live. Finding someone else shining in the void gives us hope that we can keep the lights on as well. If there is alien life on Proxima Centauri b who have reached consciousness like us, they may be peering back at us with their own telescopes, wondering if they are alone in the universe just as we do. What are your opinions on it? Do you believe Proxima b is inhabited by aliens? Let us know what you think in the comments section below. Please consider subscribing to the channel if you enjoyed the video.